We want to find the partial fraction decomposition of this rational expression, and we see it's a linear factor in the denominator but repeated. So when we set this up, we have negative 5 minus x over x minus 1 squared equals, and first we would have a fraction with this x minus 1 squared, but if we were looking for what fractions could have been combined to have this common denominator, there could have been an x minus 1, because if we got the common denominator between these, it's x minus 1 squared. If your repeated factor was to the third power, you would have a fraction with the denominator of x minus 1 cubed, another one with x minus 1 squared, and then one with x minus 1. So you need a fraction for each lower power when you have a repeated factor. Okay, let's clear this equation of fractions. So we're going to multiply by x minus 1 squared, and that will cancel there. We're going to do x minus 1 squared, and that will cancel that. And we're going to do x minus 1 squared, and the denominator will cancel one of those in the numerator. Okay, so it looks like we have negative 5 minus x equal a plus b times x minus 1. So first of all, we are going to let x equal 1. That will zero out the b. And when we put in 1, we'll have negative 6 equal a. So we found our a, and it's negative 6. Now I don't have an x, any kind of an x with the a term, so what we're going to do is just pick a convenient or easy to plug in x, and I always like to do 0 because that's easy. And if I put in 0, I'll have negative 5 equal, I'm going to put in the a that I found, which was negative 6, and then plus b times putting in 0, that'll be minus 1. So now I will be able to solve for b. We can add 6 to both sides, and it looks like negative b equals 1. So b, multiplying both sides by a negative 1, will be negative 1. So if we wrote down our final answer, a was negative 6, and that was over x minus 1 squared, and then we have minus 1 for the b, and that's over x minus 1.